NFTs are one of the hottest trends inside the blockchain and Web 3.0 space. We've seen a Cambrian explosion of new NFT projects hit the scene, some of which have soared to million-dollar valuations and beyond. And because of this, NFT marketplaces have become some of the most explosive, popular applications on the blockchain to date. Applications like OpenSea and a whole lot more. And in this video, you're going to learn how to create an NFT marketplace from scratch. This is an amazing project to learn the fundamentals of blockchain development, how NFTs work, and also use this project for your portfolio if you're trying to land a high-paying Web 3.0 job. So you don't have to be an expert to get started on this tutorial today. You'll learn everything as you go, the programming languages, the frameworks, the skills, the technologies, how to create the smart contracts, how to write the tests, how to create a website, and put it on a blockchain. So I'm super excited for you to learn this today. And if you're new around here, hey, I'm Gregory, and on this channel, I turn you into a blockchain master. So if that's something that you're interested in, then smash that like button down below for the YouTube algorithm and subscribe to this channel. And if you want to learn how to master blockchain step-by-step, start to finish, then head on over to dappuniversity.com/bootcamp to get started today. All right, so let's jump into this. So, if you're not new around here and you've been watching this channel for a while, then I actually want to introduce you to somebody who's going to help us with this tutorial today. So I've invited Ethan on the channel who's going to walk you through this entire process step by step. He's an expert in this topic, and he's going to do a great job at explaining this and showing you everything that you need to know along the way. All right, so welcome, Ethan. What are we talking about today?
So today, I'm going to teach y'all how to build a NFT marketplace like OpenSea from start to finish, from scratch.
Awesome. Yeah, this is going to be super exciting. NFTs is one of the biggest things drawing people to the crypto blockchain space right now. OpenSea trading volumes absolutely exploded. And I'm super excited to bring Ethan on today. He's going to do a great job of explaining this and showing you how to code this out step by step. So let's jump in and get started.
Let's take a look at the app we're going to build today in this tutorial. This app will have the same core features common across all of the most popular marketplace apps in the NFT space right now. It lets you buy and sell NFTs with Ether, as well as view the ones you've purchased or listed on the marketplace. I'm going to walk you through, step by step, how to build each layer of this application. We're going to spin up a development blockchain, create Ethereum smart contracts, write tests against them, and build a client-side website so that anyone can use the app. You don't need any prior coding experience to follow along with this tutorial. I'll explain everything assuming you know nothing. Even if you have no idea what an NFT or blockchain is, that's okay. I'll go over what those things are before we start coding. And one last thing before we get started, if you want to see more full-length coding tutorials like this one, please leave a like and subscribe to this channel. And if you enjoyed the video, want to take the next step, become a blockchain developer as soon as possible, head on over to dappuniversity.com/bootcamp to get started today. First things first, let's go over what a blockchain is, and then we'll cover NFTs. If you're already familiar with these technologies, feel free to skip ahead using the timestamps linked in the description down below. So what is a blockchain and why do we need it? In essence, a blockchain is a distributed ledger that powers decentralized applications, or dApps for short. A dApp is different from most traditional web applications in that the client-side website, the part of the app that users interact with, doesn't talk to a centralized server that connects to a database. Instead, a dApp relies on the blockchain to store data, but not just any type of data that represents value. So you might be asking, why should we use a blockchain as opposed to a regular web app to store value? Well, the problem is that if, for instance, someone wanted to make a digital currency using a centralized database with a server, everyone who held the currency would have to trust that the person in control of managing the database would not arbitrarily change people's balances without their permission, and the developers of the server don't change the app's source code. Blockchains provide a solution to this. Because they are decentralized and immutable, you can create a digital currency or a digital representation of any asset for that matter using the blockchain. They circumvent the need for trust. So how do blockchains accomplish this? Well, a blockchain is made of a network of computers called nodes, which each contain an arbitrary copy of all the data contained within the network. You can gain access to the entire network by connecting to any one of these nodes. The data is stored in bundles of records called blocks that are chained together by the preceding block all the way down to the genesis block. When a new transaction occurs on the blockchain, all of the nodes execute the transaction in order to verify it and achieve consensus. Once that happens, there's no way to revert or modify the transaction. It stays on the blockchain forever. On the Ethereum network, you can also deploy smart contracts, which are Turing-complete programs that run on the blockchain. Smart contracts allow you to build any arbitrary application that handles business logic or agreements between different parties in a trustless manner. Using smart contracts, you can create Ethereum-based tokens, exchanges, crowdfunds, or auctions, to name just a few. But for this video, we're going to build just 2 smart contracts that will power our NFT marketplace. One that represents a collection of NFTs, and another that allows users to buy and sell them. An example of a real-world NFT marketplace app out there is OpenSea, and at the time of recording this video, not only is it the largest NFT marketplace, but it's also the most popular Dapp in the world. It goes to show just how popular NFTs are right now. But what exactly are NFTs? An NFT is a non-fungible token, which means that it can't be interchanged for another NFT within the same collection. So why is each NFT worth differently? Well, unlike regular fungible tokens like Ether, Bitcoin, or even the US dollar, it matters which NFT you own. For instance, the first Bitcoin ever mined is worth the same as the last Bitcoin mined. But for NFTs, each one has unique qualities about it that make them appear more or less valuable compared to any other NFT. NFT smart contracts associate each NFT with an ID and a link to where the content of the NFT can be found on the web. This content can be an image, piece of music, or even a video, but most of the time it's just an image. Storing large files like this directly on the blockchain is very expensive and sometimes impossible. So as a workaround, these files are normally stored on a decentralized file storing system like IPFS, and the hash that points to where these files are located are stored on the blockchain. An NFT smart contract also keeps track of the owners of each NFT. There are special functions on the contract that allow us to transfer our NFTs to new addresses. We're going to write a marketplace contract that interacts with these functions on the NFT contract to allow users to buy and sell NFTs. When a user wants to list their NFT for sale, they will call a function that will transfer their NFT to the marketplace, and the marketplace will keep track of the seller of the NFT and the price they want to sell it at. Users can buy any listed NFT by calling a function that transfers the amount of Ether the NFT was priced at from the buyer to the seller, then transfers the NFT from the marketplace to the buyer. Also, our NFT contract will have a mint function that will allow sellers to create new NFTs and then list them on the marketplace. Now let's start installing the dependencies we need for blockchain development. The first thing we're going to need to install is Node.js. You can install it directly from the website right here. And if you're not sure whether you have it installed yet, you can open up a terminal and type the following command, node-v, and it should output the version of Node you have installed if you have it installed. And I have version 17.0.1. And for this tutorial, I recommend installing a version of Node that's greater than or equal to 16.14 or less than or equal to 17.0.1 to avoid dependency issues. The next dependency we need is Hardhat, which is a smart contract development framework. We can use it to write smart contracts in the Solidity programming language, write tests against them, and even boot up a local development blockchain with a few commands and then deploy those smart contracts to it. For this tutorial, I'm going to install a very specific version of Hardhat, and I suggest you do the same. So in your terminal, type npm install --save-dev hardhat at 2.8.4, and then press enter. Lastly, we're going to need to install MetaMask, which will turn our browser into a crypto-compatible browser. To do that, go to the metamask.io website, then click download, click this install MetaMask for Chrome button, go through the setup steps, and once you've done that, go to your Chrome extension settings, and then make sure MetaMask has been enabled. And you know it's been enabled once you see this Fox icon at the top right-hand corner of your screen. All right, now let's start setting up the project. Now, instead of setting everything up manually, we're going to use a starter kit that I created. You can find the link to it in the description. So go ahead and copy it. Then open up a new terminal. Type git clone, paste in the URL, add a space, and then we're going to set the name of the project to NFT Marketplace. Then hit enter. Okay, once that's done, go ahead and enter into the directory by typing cd NFT Marketplace. Now I'm going to install all of the project-specific dependencies by typing npm install. Hit enter. All right, once that's done, you know it was successful if it said added packages right here. It's okay if you see any warnings. It's not ideal, but as long as you don't see any error messages, then the installation was successful. Now, before we move on, we're going to need to install a few more dependencies not included in the starter kit. So if I go back to the application preview, you see that whenever I click any of these navigation links, the app routes me to a new page. We need to install the React Router DOM dependencies to support this feature, since it doesn't come bundled with vanilla React. So to do that, go back to your terminal, type npm install react-router-dom at 6, then hit enter. All right, once that's done, let's go ahead and install the next dependency that we're going to need, which is the IPFS HTTP client. We're going to use this to upload the content of the NFT to IPFS before we mint it using this create and list NFT form. So we go back to our diagram, we see that our NFT contract stores the hash of where the image is located in IPFS. So go to the terminal, type npm install IPFS-http-client at version 56.0.1, then hit enter. Whoops, should be a dot, not a comma. The last dependency we're going to add to our project is the OpenZeppelin contracts library. This is essentially a library of a bunch of secure pre-made contracts that developers can import into their projects when writing a new contract, so they don't have to constantly reinvent the wheel for a lot of common smart contract patterns and implementations. So we're going to use this to import the ERC-721 NFT standard. We're going to go look at that standard more in depth once we get to it. So go ahead and enter npm I at OpenZeppelin/contracts and then at 4.5.0, then hit enter. All right, with all the dependencies installed, let's go ahead and get a tour of the project. So I'm going to open up the project with the VS Code text editor. You can use whichever text editor you'd like. I'm going to do it from the terminal using a symlink by typing code space dot, then hitting enter. So this is a Hardhat and React project combined into one. Hardhat gives us all the features we need to create smart contracts, write tests against them, and deploy them to a local blockchain. And React allows us to create a client-side website that talks to these smart contracts. So I'm going to show you what's inside of here. The first place to take note is this hardhat.config file. This is where we specify the version of Solidity that we will be using to compile our smart contracts, as well as where the smart contracts live in the project. Now, if you've used Hardhat before, this may look a little new to you. That's because I've configured Hardhat to put the smart contracts in a place that they're not normally at by default. This is because I want to be able to access the contracts from the client-side portion of the application. And in just a moment, we're going to look more in depth at how that works. Moving on, let's go ahead and check out this source directory. So our app is organized into two different parts. We have this backend component found in this backend directory, and this is where all of the smart contract source code will live, as well as the test for those smart contracts, and a deployment script, which we can run to deploy these smart contracts to our local development blockchain. I'll explain what this code does once we get to it. Moving on, we have this front-end directory, and this is where the code for our client-side application will live. And the code is made up of components, React components, which are reusable pieces of code that come standard with the React framework. And we also have this package.json file, which contains all of our project-specific dependencies. And as you can see, we included the OpenZeppelin contracts, the IPFS, HTTP client, and React Router DOM manually. Next, let's go ahead and boot up the web server of the client-side application to make sure that everything was set up properly. I'm going to do that from VS Code's built-in terminal. Type the following command, npm run start, hit enter. And that command should have opened up the client-side app in a new browser tab like this. So here's the Dapp University starter kit. We're using Bootstrap to style it. We've used it to create this really nice looking navbar, font, and image logo. And we're going to use Bootstrap quite heavily to make our application look really nice without having to code out a bunch of raw CSS. So eventually we're going to turn the application from this into this. So to go from the starter kit to the completed app that I just previewed to y'all, we're going to need to modify the starter kit code located inside the app.js directory. So go ahead and return to your terminal, open up a new tab. We're going to use this new tab to develop our smart contracts. We can leave the web server running in the background. We're eventually going to return back to it once we're done with the backend portion of the app. Okay, let's start by creating a new directory for the contracts by typing mkdir source backend contracts and enter. Okay, and then let's go ahead and create our first contract inside of that directory. I'm typing touch source backend contracts nft.sol. Hit enter. Okay, let's check it out. Boom, and here it is. So we're going to start by pasting in the license identifier like so. We're going to be using an MIT license. Next, we're going to indicate to the compiler which version of Solidity we're going to use with this pragma statement. So pragma, Solidity, and then we declare the version number of Solidity we're using. So we're using 0.8.4, which is the same version that Hardhat expects us to use. And we end every single line of code with a semicolon. Next, we're going to import the ERC-721 URI storage contract from the OpenZeppelin library like so. So the ERC-721 standard is an agreed upon standard that defines the set of all functions that a NFT contract should have at the bare minimum. This standard was designed so that any NFT contract is compatible with any Dapp, wallet, or marketplace that interact with it. Plus, it saves developers a lot of time. It prevents them from having to reinvent the wheel each time they create a new NFT smart contract. They can just import this ERC-721 contract into their NFT contract and append it where needed. And that's exactly what we're going to do. But before we do that, let's take a closer look at the functions that make up this standard. So you don't have to know what each of these functions do, but you should focus on this transfer from and approve to function. These are the main functions that we will be calling from inside of our project. This transfer from function transfers a specific NFT, passing in the token ID, from one account, passing in a from address to another, passing in a to address. And then this approve function allows a particular address. Normally it's a contract, but it can be a user's address, an externally owned account rather, to spend a particular NFT that we own. Yeah, whenever we transfer NFTs to the marketplace, the user will have to call this approve function first. We're going to examine these functions more in detail once we start coding out the marketplace contract. Next, we're going to create the contract like so. Contract, followed by the name, NFT, then curly braces. Inside these curly braces is where the code of the NFT contract will reside. Now, we also want to inherit all the functions from the ERC-721 standard, which we've imported here. And we can do that using the is keyword. So we could say NFT is name of this, paste it here. Sweet. Now our NFT contract abides by the ERC-721 standard. Next, we're going to declare a state variable that keeps track of the number of tokens. Now, state variables are variables that are declared within a contract, but outside of any functions within that contract. And only the functions from within the contract can modify these state variables. And these state variables are stored to the blockchain. And whenever a function modifies a state variable, you are modifying the state of the blockchain, and therefore it costs gas to call said function. So I'm going to give a more concrete example of that once we code out the mint function for this NFT contract. So to declare a variable, we first have to declare the data type of the variable. So for the token count, we're going to declare it as an unsigned integer. So you can abbreviate that by typing uint. And then we follow that up with the name of the variable, so token count. And the reason why we have to specify the data type of the variable is that Solidity is a statically typed language, which means that the data type of a variable cannot change. It's determined at compile time. So we have to be explicit with the data type for each variable we declare. And we also want to allow this token count to be read outside of the contract. So we'll mark it as public as well. Next, let's create a constructor function, which is a special function that's called only once after the contract has been deployed to the blockchain. To do that, we're going to type constructor parentheses followed by curly braces. Inside these parentheses is where we pass in the arguments for the constructor function. And inside these curly braces contains the code of the constructor function that will be executed when called. So for this constructor function, we're not going to put anything inside the curly braces or pass any values to it. But what we are going to do is call the constructor on this inherited contract. So the ERC-721 contract. We can do that by typing ERC-721 and then pass in the arguments for this constructor. So the first one will be the name of the NFT. So we're going to call it Dapp NFT, followed by the symbol of the NFT, which I'll set to, Dapp in all caps. Next, we're going to write a function that will allow us to mint new NFTs. So to do that, we'll use the function keyword, followed by the name of the function, parentheses, and this function will accept one input, and that's going to be type string. And this will be the token URI, which is the metadata of the NFT, essentially the link to where the content of the NFT can be found on IPFS. So I'm going to pass that in. And whenever you're passing strings to a function, you need to specify the memory location of the argument. So I'm going to specify that it's in memory. And then we need to set the visibility of this function. So we want this function to be called from the outside, but not from any functions within this contract. So we'll use the external keyword for that. And we also want this function to return the current token count, which will correspond to the ID of the newly minted token. So to do that, we'll use the returns keyword, then specify the return data type, which will be an unsigned integer. Inside the function body, we're going to increase the token count by 1 using this ++ increment operator. Then we're going to mint a new NFT by calling the internal safe mint function, which came from the inherited ERC-721 contract. And for the first argument, we pass in the address that we're minting for, which is the caller of this contract, which we can reference from the global msg.sender variable, and the ID of the token, which we can get from the token count. Then we're going to call another internal function, this time a function that sets the metadata for the newly minted NFT. And we pass in the ID of the NFT for the first argument, and for the second, we pass in the token URI that we passed into our call to the mint function. Then after that, we return the ID of the token we minted by returning the token count. And that's it. We've completed the entire NFT contract. That's all we needed. We just needed one function to mint NFTs. So one thing I should note before I continue is that in Solidity, if you declare a variable but don't initialize it, that Solidity will automatically initialize that variable with the default value of that variable's data type. So the default value of an unsigned integer is 0. So therefore, the token count is initialized with 0, even though we don't explicitly write that. Solidity does it automatically. All right, now let's try to deploy this contract to the blockchain and then interact with it from the hard hat console to make sure that we've set up the project correctly. First, we need to spin up a local blockchain. The hard hat framework comes bundled with a blockchain that we can run from our terminal. So to do that, go ahead and create a new terminal tab and then type the following command: npx hardhat node, then hit enter. And as you can see, the local blockchain comes with 20 unlocked accounts, each funded with 10,000 fake ether. And here are the addresses of the accounts and then the associated private keys. Please do not use any of these accounts to store any real money, because everyone who's seen this video can gain access to these accounts and compromise your funds. All right, now that we've booted up a local development blockchain, let's check out this scripts directory, open up this deploy.js file. Whenever we run this deploy script, we essentially put our smart contracts on this blockchain. And we also save a copy of the smart contracts ABI and the smart contracts address to this front end directory. We do that so our client-side application can create a JavaScript instance for our smart contracts. And to do that, it needs the contract's address and ABI. Our front-end website has to create these instances in order to read and write data from our smart contracts. Don't worry if that seems a little confusing. It'll make a lot more sense once we start building out the front end. I just want to explain the purpose of this save front end function within the deploy script. We can do that by calling the getContractFactory method on the ethers object. Right now, this deploy script is incomplete because we haven't implemented the code that performs the action of deploying the NFT contract to the blockchain. So we can do that in 2 lines of code, like so. So this first line of code fetches a contract factory, so specifically an NFT contract factory. And all this, if you want to know more about what a factory is, you can read it from the ethers documentation. So it says that the contract factory sends a special type of transaction and a init code transaction, where the init code will be evaluated and the result becomes a new code to be deployed as a new contract. So in other words, we require this contract factory to deploy the NFT. So we get an NFT contract factory, and we can fetch that by calling the getContractFactory method on the ethers object that's injected into our hard hat development environment. And all ethers is just a library for interacting with Ethereum nodes. And then we pass in the name of the contract that we want to get a factory for. And then we call the deployed method on the factory to fetch a deployed copy of the NFT. So for each of these function calls, we need to use the await keyword because each of these calls are asynchronous. They return a promise, and we have to wait for that promise to resolve before we get a return value. And the reason behind this is that these are both calls to the blockchain, and the blockchain is slow. It returns values asynchronously. So that's why we have to use this await keyword. If you want to know more about how promises work, you can read the developer Mozilla documentation about it right here. I'm not going to go into too much detail about it. All you need to know is that it's used to handle asynchronous function calls. All right, now let's pass in the NFT contract and name of the contract to this save front end files function. Alrighty, now let's go ahead and run this deploy script. So in your terminal, enter the following command: npx hardhat run source backend scripts deploy.js. Then we got to specify the network. So -- network localhost. Then hit enter. Sweet. We have successfully deployed the NFT smart contract to our local blockchain. Now let's go ahead and enter into the hardhat console by typing npx hardhat console, then hit enter. So this hardhat console is an interactive JavaScript environment for interacting with our blockchain and any smart contracts deployed to it. So let's go ahead and fetch a deployed copy of the NFT smart contract. We can do that by typing const contract await, then ethers. I'm going to use this getContractAt method on the ethers global object. So getContractAt. For this method, we first pass in the name of the contract we want to get, followed by its address, each within quotes. So you can get the contract from here, contract address rather, copy it, paste it within these quotes, and then hit enter. Sweet, it says it's undefined, but we enter in the variable name, the console contract will get the output, and sweet, it outputted a contract object which contains all of the external functions of the contract, essentially the interface. So we're going to call this token count function to output the token count on the NFT contract. So let's go ahead and type const token count await contract dot token count parentheses. Hopefully it works. Darn it. Okay, I see what's wrong. My bad, guys. I forgot that when I was entering into the console, I need to specify the network. So let's go ahead and exit out of the console by typing .exit, and then go back to the console command, and then type -- network localhost, then hit enter. Okay, now let's retype those commands. Sweet. And then we'll do token count like this. Awesome. Type token count. Sweet, big number, value 0. Awesome. Exactly what we wanted. Now let's fetch the name of the NFT, which should be Dapp NFT. So do that like this. Name, await, contract. Replace token count with name, and then hit enter. Log name. Sweet, Dapp NFT. Now let's do the same thing for the symbol. Symbol equal to await contract dot symbol. Enter symbol. Sweet. DAPP. Exactly what we expected. Now that we've finished building out the NFT contract, deployed it to the blockchain, and interacted with it from the hard hat console, let's go ahead and build out our second smart contract for the marketplace. So if we go back to the diagram I showed y'all earlier, the marketplace contract is the contract where users can list their NFTs as items to be sold by potential buyers. So let's go ahead and create that. So let's create a new file inside of this contracts directory. Right click, new file. I'm going to call it marketplace.sol. Now let's go ahead and copy and paste the same license and pragma statement that we implemented in our NFT file onto the marketplace. Next, we're going to import the interface for the ERC-721 NFT standard from OpenZeppelin, like so. So before I continue, let me briefly explain what an interface is. In Solidity, you can interact with other contracts without having to know its code using an interface. So for instance, our marketplace will need to call this transfer from function on the NFT, but from the perspective of the marketplace, it doesn't need to know the code behind this transfer from function. It just needs to know how to call it. So essentially, an interface just defines how to call all the externally accessible functions of a smart contract. Next, we're going to implement a reentrancy guard contract that will protect the marketplace from reentrancy attacks. I'll explain more about how a reentrancy attack works once we implement the non-reentrant modifier on the marketplace functions. Next, let's declare some state variables. Our marketplace will charge fees for each NFT purchased. So we need to keep track of the account that receives those fees, as well as the fee percentage on the sales. So each of these variables will be public, and the fee percent will be type unsigned integer. The fee account will be type address, and it will also be payable so that the fee account can receive the Ether fees. And both of these variables will be marked as immutable, which means that they can only be assigned a value once. And we will initialize both of these inside the constructor of the marketplace. Next, let's write the constructor function that will initialize the fee percent and fee account. So it'll look like this. We pass into it the fee percent and assign that to the fee percent state variable. And then for the fee account, we don't pass any addresses into it. We can reference the msg.sender and assign that to the fee account because we want to set the fee account to the deployer of this contract, and only the deployer can call this constructor function. And we cast the deployer as payable. So before I start writing the functions that allow users to list their NFTs on the marketplace and to buy those NFTs, let's go ahead and finalize our setup by deploying the marketplace on the blockchain. So we can do that by modifying this deploy script. All right, now we're going to deploy the marketplace in the same way that we deployed the NFT, except we're going to pass in the fee percent inside the deploy method because the marketplace constructor accepts fee percent as an argument. So we have to pass that to the deploy method. Then we want to console.log the marketplace address and then save the marketplace files to the front end. All right, now let's go ahead and run the deploy script. So open up terminal, and if you are inside the hard hat console, you can exit out of it by typing .exit, hit enter. Now let's run the deploy script. Sweet, we have successfully deployed both the NFT and marketplace contracts. So now let's enter back into the hard hat console and interact with the marketplace contract. So let's fetch it like this: const marketplace is wait ethers.get contract at. Okay, and we'll pass in the name of the contract, capital M marketplace, followed by the contract's address right here. Copy it, paste it between the quotes. Okay. All right, hit enter. Awesome. Marketplace. Now let's fetch the fee percent on the marketplace. Fee percent await marketplace dot fee percent. Okay. Awesome. The value is 1, just like we set right here. Now let's fetch the fee account. Fee account. Okay. Sweet. And this fee account address should be identical to the first account listed here on the local development blockchain, because by default, Hard Hat assumes that the deployer is this account. So let's copy it, see if it's identical. Sweet, and it is. So one quick thing I should mention before we move on is that you may have noticed when we ran the deploy script for the second time that the deployer's account balance that we logged right here has decreased from its original 10,000 Ether. This is because whenever you deploy a contract to the Ethereum blockchain, you are updating the state of the blockchain. You're creating a transaction. And whenever you do that, you have to pay a fee for that. And that fee is paid with Ether. All right, now that we have finished setting up the deploy script, let's go ahead and start programming the marketplace. We're going to start with the function that will allow us to list NFTs for sale, and then the one that lets us buy them. Now, each time we implement some functionality into the contract, we need to test it out to ensure that it's doing what we expect it to do. We could run these tests from the hard-hat console like we have been doing, but that's slow and inefficient. The better way is to write test scripts that automate this process. Testing smart contracts is very important because once a contract has been deployed, you can't change its code. It's not like web development where you can easily push bug fixes after you've deployed your app. The cost of bugs for smart contract developers is much higher. So writing robust tests for your smart contracts is an integral part of the development process. So the hard-hat framework lets us write tests for our smart contracts, and we can create a directory for them inside of this backend folder. We're typing mkdir source backend test. Sweet, and that created a new test folder. Inside of it, we can create a new test file named NFT marketplace.test.js. So this file will contain all of the tests for both the NFT and marketplace contracts, and they're going to be written in JavaScript using the Waffle testing framework provided to us by Hardhat. Now, in addition to the Waffle testing framework, we're going to use the chai assertion library within our tests to conveniently compare values. We can use it to compare return values to expected values, among many other things. So it comes with should, expect, and assert declarations. So let's go ahead and import chai and then create our tests. So we'll write describe, and then we'll pass in the name of the test. So NFT marketplace. Then for the second argument, we'll pass a callback function. So an anonymous callback function, a function without a name. And inside of here is where we'll write all of the tests. So in order to write tests against them, we need to get the contract factories for each, just like we did inside of our deploy script using the ethers object injected into our hardhat development environment. Next, we need to fetch the signers for each of these test accounts on our hardhat development blockchain. You could think of signers as abstractions of Ethereum accounts that can be used to sign and then send transactions to the Ethereum network. So to get them, we can write await ethers dot get signers, and this will return an array of signers. Now we want the first signer returned in this array to be the deployer, and the second to be address 1, the third address 2. Now for this to work, we need to declare a variable for each of these signers up here using the let keyword like this. Next, we're going to deploy the contracts just like we did inside of the deploy script. And then we need to declare a variable for the NFT and marketplace contracts up here. NFT marketplace. All right, now we have everything set up to start writing our first test. But before we do that, let's wrap all of this code inside of a before each hook like this. So because we're going to be writing multiple tests, this before each hook will prevent us from having to copy and paste all of this code at the beginning of each of the tests. The before each hook does that for us automatically, so we only need to write this code once inside of it. Now let's write our first test to make sure that each contract was deployed to the network correctly. We can do that by writing describe, and then deployment, pass in a callback, and inside of here, we'll create the first test like this. It should track name and symbol of the NFT collection. We'll pass in an asynchronous callback. We're going to use expect from the chai library to make sure that the name of the NFT is correct. So we can do that by typing expect, and then we're going to fetch the name of the NFT like this, await nft.name. All right, and say to equal, and this is where we put in the expected value. So we expect it to equal Dapp NFT. Okay, now let's duplicate this code. Do the same thing for the symbol. So symbol equal to all caps Dapp. Okay, let's do a quick overview of the code, make sure everything looks good before I run the test. Oh, this fee percent is undefined. Let's go ahead and define that up here. Let the percent, assign it to 1. Okay. Now let's run the tests. Open up a terminal, type npx hard hat test. Nice. You see how fast that was? Remember how long it took for us to test for the name and symbol using the hard hat console? Automatic testing like this saves us so much time, especially for the more complicated tests like the ones we're about to write. Next, we're going to test the deployment of the marketplace contract, just like we did from the hard hat console, like this. So we're going to track the fee count and fee percent using expect, like we did for the NFT collection. Next, let's check that the minting functionality on the NFT contract works. So we do that by like this, saying describe minting NFTs, and then we'll say it should track each minted NFT, a sync function, and inside of here, address 1 will mint an NFT by connecting their account to the NFT contract, calling the mint function on it and passing in the URI for it, and passing in URI metadata for the token. So you can set that variable up here. Let URI equal to sample URI. And moving on, we first checked that the token count for the NFT contract is equal to 1, and the balance, NFT balance for address 1 is equal to 1, and that the token URI for the first token is equal to the URI we set up here. Next, let's test what happens when address 2 mints an NFT. We should expect that the token count increases to 2, the NFT balance of address 2 should equal 1, and the token URI for token 2 should equal the URI we set up here. All right, and that's a really good basic test to start off with. We've covered the deployment of each of the contracts as well as the minting functionality of the NFT contract, which is all that we've covered so far. All right, now let's go ahead and finish building out our marketplace. So we know that the marketplace contract needs to keep track of each of the NFTs listed for sale. You could think of these things as items, okay? Marketplace items specifically. So each marketplace item has some data associated with it. It would include the ID of the NFT, the address of that NFT's contract, the address of the seller, the price that the seller set the NFT to. So we can group all of this data together into this thing called a struct. Okay, and we'll call it an item. You could think of a struct as the Solidity equivalent of JavaScript objects, if you're familiar with that. It allows you to create complex data types with multiple different fields. For the struct, we specify an item ID and an instance of the NFT contract associated with the NFT, the ID of the NFT being put for sale, the price it was set at, and the seller, as well as whether the NFT has been sold or not. The sold field is of type Boolean, which means that it can only hold either a true or false value. Now that we have defined our item struct, we need something that can store all of the different items. We can do that using a mapping, which is a special data structure in Solidity. It is a key value store, and you can look things up based on a key and get a value back. The item ID will be the key, and the item struct will be the return value. We can define our mapping like this. Mapping, and then inside parentheses, we specify the data type of the key, be an unsigned integer, then the data type of the return value should be an item, then we name, then we can set the name of the mapping. I'm going to set it to items, and we want this mapping to be publicly accessible, so we'll say that it's public. Now let's create the function that makes items. Function make item, and we're going to pass the NFT contract of the NFT to be listed. So to underscore NFT, and we're going to make this an instance of an ERC-721 contract by making it the data type ERC-721, which we imported from here. So from the front end, the user will pass in the address of the NFT contract, and then Solidity will automatically turn it into an NFT contract instance. Next, we will input a token ID as well as the price of the token. And the function will be external, and we're going to add the non-reentrant modifier to it, which came with the inherited reentrancy guard contract. What this non-reentrant modifier does is it prevents bad guys from calling this make item function and then calling back into it before the call to the make item function, the first call that is, has finished. If you want to know more about how reentrancy guards work, you can check out OpenZeppelin's documentation about it right here. Inside the function body, let's check to make sure that the input price is not 0. We can do that using a require statement like so. The require operator first accepts a condition, and if the condition, in this case, price greater than 0, is true, then the rest of the function is executed. And if the condition is false, the function stops executing, and any changes made to the state are reverted. Then for the second input, it accepts EVM revert error message. Next, we're going to transfer the NFT that the user wants to list by calling the transfer from function on the NFT argument, setting the from argument as the account that called this function, the to argument as this contract, and then the token ID argument passed into the function. Next, we're going to add a new item to the items mapping. So we initialize a new item and assign it to the items mapping, setting the key as the item count. We can initialize a struct by calling it like a function, passing in the struct's data fields. For the item ID, we pass the item count, NFT for NFT, token ID for token ID, price for price. Then for the seller, we pass in the account that called the makeItems function and cast it as payable. For the sold field, we set it to false. Lastly, I want this function to emit an event. Now, an event allows us to log data to the Ethereum blockchain. You can use events as a cheap form of storage or a way to update user interfaces when listened for. So let's go ahead and define an offered event at the top of the contract below this struct. Then we're going to emit it at the bottom of this makeItem function. So to define an event, first use the event keyword, followed by the name of the event. So offered, then parentheses. And inside of these parentheses is where you define each field of the event. So for the offered event, we're going to log the item ID, the NFT contract, the address of the NFT contract, the token ID, the price of the item, and the address of the seller. And the NFT and seller fields, we're going to set as indexed. This will allow us to search for offered events using the NFT and seller addresses as filters. Then we're going to emit an offered event like this, passing in basically the same data fields as the item struct minus the sold field. And for the NFT instance, we fetch its address by casting it in the address operator. So we're going to describe making marketplace items. And inside of here, let's first create a before each hook that mints an NFT for address 1. And then address 1 approves a marketplace to spend that NFT by calling the set approval for all function on the NFT contract. So why do we need to call the approve function on the marketplace? Well, in order for this transfer from function to work, the caller of the makeItem function needs to have approved this marketplace contract to transfer their NFT on their behalf. For the first test, let's check for the success case. So it should track newly created item, transfer NFT from seller to marketplace, and emit offered event. First things first, address 1 will offer their freshly minted NFT for sale on the marketplace at a price of 1 Ether by calling the makeItem function, passing in the NFT address, the token ID, and the price set in way of the NFT they want to sell. So let me briefly explain what way is. You can think of it as the smallest subdivision of Ether, essentially the penny of Ethereum. So if we think of the US dollar, it goes up to 2 decimal places. There's no further subdivision after the penny. But for the Ethereum cryptocurrency, there is 18 decimal places. So that means that 1 ether is equal to 10 raised to the 18th power way. So that's 1 followed by 18 zeros. And this two-way function that I wrote right here automatically converts ether into way using the ethers.utils parse ether method. Now, the reason why we have to pass a way value instead of an ether value for the price argument is that you can't represent decimal values in Solidity. You can only represent integers. So we have to represent ether in our smart contracts as its smallest subdivision, way. Moving on, we then check inside the transaction log of this function call to make sure that an offered event was emitted with these arguments. Next, we check that the marketplace is the new owner of the NFT using the owner of function on the NFT contract, passing in the marketplace address. Then we check that the item count on the marketplace is equal to 1. And lastly, we fetch the newly created item from the items mapping on the marketplace contract, passing in a key of 1 to represent item ID 1. Then we check that item ID is equal to 1, NFT is equal to the NFT address, token ID equal to 1, price is equal to the way value of 1 ether, and sold is equal to false. All right, that just about does it for the success case test. Now let's write a test that handles the failure case. For this test, it should fail if the price is set to 0. That's because if the price is 0, it will not pass this condition set in the require statement of the make item function. So we call the make items function, passing in a price of 0. Then we expect it to be reverted with this error message: price must be greater than 0, which is the same message emitted by this require statement when this condition fails. All right, and that completes the making marketplace items test. Now let's run the entire test script to make sure that everything is working as it should. So npx hard hat test, hit enter. Sweet, sweet. Everything passed. All right, now let's implement the final function on the marketplace contract that will allow users to purchase NFTs. So we're going to name the function purchase item. It will accept as input the item ID that the user wants to purchase. The visibility will be external, and we're going to mark it as payable so that the user that's calling this function can send ether with it. And eventually this ether will be sent to the seller of the item ID and a small portion to the fee account. And we're also going to apply the non-reentrant modifier like we applied to the make item function. So before I start coding out the body of this purchase item function, I'm going to write this get total price public function. This function will get the price of an item, the total price of an item. So that's the price of the item set by the seller plus the market fees. And this function will be view because it won't be modifying any state variables. It will only be reading them. And we're going to set the visibility as public because we want to be able to call this function from inside of this purchase item function and from what outside of the contract, because whenever a user wants to buy an item, we need to know how much ether they need to send with the call to the purchase item to cover the price of the item set by the seller plus the market fees. And this function returns that price. So to fetch the total price, we're going to fetch the price of the item from the items mapping, like so. Then we're going to multiply that price by the sum of 100 and the fee percent. And then we're going to wrap this whole thing in a return statement. Sweet. And that completes this get total price function. All right. Now inside of this purchase item function, let's get the total price of the item and assign it to a local variable, like so. Next, let's get the item from the items mapping and store it in a variable like this. Since we're creating a variable that's of a complex type, so a type struct, we have to declare the storage location of the variable. So we're going to say that it's from storage, which means that this variable is reading directly from this storage mapping. It's not creating an in-memory copy of the item. Next, we're going to check that the item ID is valid by ensuring that it's greater than 0 and it is less than or equal to the item count. We're also going to make sure that the ether sent with this function call, which we can reference using the global msg.value variable, is greater than or equal to the total price. And for the final require statement, we're going to check that the item that the user wants to purchase has not already been sold. This bang operator evaluates this item.sold to the opposite Boolean value. So if it's not sold and the item.sold outputs false, this whole condition will output to true. But if item.sold is true, then the condition will be false and the function will revert. Next, we're going to pay the seller by calling the transfer method on the seller's address, passing in the price of the item, and then we're going to transfer the fee to the fee account address, passing in the total price minus the item price, which will evaluate to the fee amount. After that, we're going to update the item as sold. Then we're going to transfer the NFT from this address to buyer or the sender of this function call. And we're going to do this by calling the transfer from function on the NFT contract, which we can get from the item struct. And then for the token ID, we pass in the token ID on the item struct. Lastly, we're going to emit a bot event at the bottom of this purchase item function, like we did for the make item function. So we first have to define it like this. The event will have pretty much all the same fields as the offered event, except we're going to add an additional field, which is the buyer. So this is the address that called the purchase item function. We're going to set this buyer field as indexed because when we're building out the user interface, we want to show all of the items that the user has purchased from the marketplace. And we can fetch that data by searching for bot events where the buyer address is equal to the account that's connected to the user interface. We're going to set the item ID as the item ID argument, the NFT as the address of the item's NFT contract, for the token ID, the item's token ID, for the price, the item's price, for the seller, the item's seller, and for the buyer, the account that called the purchase item function. Woohoo! And that completes the marketplace contract. Now all we have left to do before we start building out the front end is to test out these two functions inside of this test script So let's get started on that. So we're going to describe purchasing marketplace items. And like with the previous test for the making marketplace items, we're going to set a before each hook inside of here. Inside the hook, address 1 first mints an NFT, then approves a marketplace to spend that NFT, and then calls the make item function to list it on the marketplace at a price of 2 Ether. All right, now let's write the test that handles the success case. It should update item is sold, a seller, transfer NFT to buyer, charge fees, and emit a bot event. First, we need to fetch the initial ETH balances of the seller and the fee account to ensure that each of their balances increases by the appropriate amount after the item has been purchased. We can fetch the signer or the account's Ether balance by calling the getBalance method on the signer object. Next, let's fetch the total price of the item by calling the getTotalPrice function on the marketplace contract, passing in 1 for the item ID. After that, address 2 will purchase the item. We can specify the amount of Ether we want to send with the call to the purchase item function by passing in a metadata object as the last argument, setting the value property of that object as the total price in way that we fetched earlier. Next, we check inside the transaction log of this call to ensure that a bot event was emitted with the following arguments. We ensure that the item ID is 1, the NFT is the NFT contract address, the token ID is 1, the price of the item is the price we set in way, and the seller is address 1 and the buyer is address 2. Now that we've purchased the item, let's fetch the final ETH balances of the seller and the fee account. Next, let's ensure that the seller's final ETH balance is equal to the seller's initial ETH balance plus the price that they set the item at. We're going to convert the balances from way to ETH because JavaScript does a poor job at adding big numbers together. Whoops, I just noticed that I did not declare this total price in way variable. So let's do that right now. Next, let's calculate the fee by taking the fee percent, dividing it by 100, and multiplying all of that by the price. Then let's check that the final ETH balance of the fee account is equal to the fee account's initial ETH balance plus that fee. Next, let's check that the buyer, which is address 2, is now the new owner of the NFT by calling the owner of function on the NFT contract, passing in the NFT's ID. Lastly, let's check that the sold field for the first item is now equal to true. All right, let's go ahead and run the test really quick to see if we made any errors. Okay, MPX hard hat test. Awesome, everything's passing. Alrighty, now let's write the final test for the project, which will test the fail case for the purchasing item function. Essentially, we're going to trigger all 3 of these require statements to ensure that they are working as expected. So we should expect the function to fail for invalid item IDs, purchasing sold items, and when not enough Ether is paid. Let's first check that it fails for invalid item IDs. So we're going to call the purchase item function, and we're going to pass a value of 2 for the item ID, which is greater than the item count, which is set to 1. So it should be reverted. And we're going to call the purchase item function again, but this time pass 0 for the item ID, which is less than 1. So it should also be reverted. Next, let's move the total price in way variable declaration outside of the success case test so that it's accessible from within the fail case test right here. Next, let's ensure that it fails when the ether sent with the call is less than the price plus the fee. So in this case, we're only sending in the price of the item that the seller set. So we should expect it to be reverted. Lastly, let's check that it fails when trying to purchase items that have already been sold. So address 2 first purchases item 1. And then the deployer account tries purchasing item 1 after it's been sold. So in that instance, it should be reverted with item already sold. Alrighty, and now we have finished writing the final test for the marketplace contract. So let's go ahead and test it. npx hard hat test. Hopefully it works. Sweet, all 7 tests passed. Now we can move on to developing the front end. But first things first, let's go ahead and deploy the completed smart contracts. So in case you forgot, we're going to run npx hard hat run source backend scripts deploy.js -- network localhost. Then hit enter. Sweet. So this is a starter kit that we began the project with. It's very bare bones. We haven't done much modification of it. But for the rest of the video, we're going to modify it to create the final product, which is this, the Dapp NFT marketplace. So we're going to turn this into a multi-page app using React routers and connect it to the blockchain and display the account we're connected to the app with at the top of the nav bar right here. We have a lot of work cut out for us, so let's get started on all of that right now. So in order for us to connect our app to the blockchain, we first need to connect our browser to the blockchain. We can do that by importing the accounts on our development blockchain into MetaMask. But before you do that, make sure you've added Hardhat Node to the list of available networks on your MetaMask. If you haven't done that yet, go ahead and click this button at the top of your MetaMask. Go down to Add Network. And then you're going to fill out all these fields with this information. Once you've done that, go back to the terminal tab that's running the local blockchain and copy the private keys for the first 2 accounts. So I'm going to import the private key for this first account into MetaMask like so. Copy it, click MetaMask, click the circle, click import account, then paste in the private key, then hit import. Boom, and go ahead and do that for the second development account. All right, now that we've connected our browser to the blockchain, let's go ahead and connect our app to it. To do that, open up the app.js file located inside the components directory. First, let's import the ethers.js library like this. This is a library that will allow us to talk to Ethereum nodes, and we've already used it within our tests and deploy scripts to connect to our local dev blockchain, and we're going to use it to do the same thing for our app, except Ethers is going to connect to MetaMask, and MetaMask is already connected to the blockchain, so Ethers will use MetaMask as its Ethereum provider. There are many different types of providers, but the provider offered by MetaMask is called a Web3 provider. So that's the one we're going to connect to. Let's go ahead and create a function inside of the function body of app that handles this connection to MetaMask. We're going to call it Web3 handler. All right, now let's instantiate a new provider from MetaMask by writing new ethers.providers, specifying the type of the provider, Web3 provider, by passing in the window.ethereum object, injected into the browser by MetaMask. Let's also fetch the accounts listed in our MetaMask wallet. This line of code will return an array of accounts, and the first account listed represents the account that's connected to the app. We're going to display the address of that account on our nav bar, so we need a way to store it. React allows us to store data on the front end, kind of like a mini database, using this useState hook. We're going to use this hook to store the account connected to the app. So this is the way useState works. First, it returns a variable that we can use to reference the stored value, followed by a function that we can use to update this stored value by passing the new value as an argument to it. We also pass to the useState hook itself the default value of the stored variable, so the value of the variable before it's set by the setter function. So we're going to set account to null by default. So let's use the setter function to store the connected account. Next, let's get the signer of the connected account from the provider like this. Awesome. We have set up our connection to the blockchain. The next step is for us to load the contracts from the blockchain. We're going to create a load contracts function that does just that. It's going to take as an argument the signer that we fetched from here, and we're going to call this function at the end of our Web3 handler function. So we're going to fetch deployed copies of the contracts using the ethers.contract method. To get a deployed copy, we have to pass in the contract's address, its API, and a signer. When we ran the deploy script, we saved a copy of each contract's address and API inside of this contract's data folder inside of our front end. So we can import that up here like so. We also need to store each contract into the state of our application using the useState hooks. We also need to keep track of when our app is loading data from the blockchain to know when to display the contents of the app. We're going to set loading from true to false once all the contracts have finished loading. Sweet. We have written the functions that connect us to the blockchain and load the contracts. Next, let's create the navbar component for our application that will contain a link to all the different routes that we're going to set up, as well as a button to connect our wallet to our application that, when clicked, will trigger this Web3 handler function. So let's get started with that by first deleting the current navbar and then creating a new file inside of this components directory. We're going to call it navbar.js. Okay. So to speed things along, I'm going to paste in some boilerplate code for this navbar file. I'm doing this because for the front end portion of this tutorial, I'm mainly focusing on how to connect your client-side website to the blockchain, not how to code out and design the user interface with HTML and CSS. So as I mentioned before, we want our app to route to a new page in our app each time they click one of these navigation links. So I'll demonstrate that by going back to the preview of the finished app. You see that if we click the create link, we get routed to create. And my listed items will get routed to localhost -3001. My listed items, my purchases, same thing. So to configure that, we need to import link from React Router DOM. Then for each nav link element, we set the as attribute to the imported link and the to attribute to a string that corresponds to the route in the URL. We're also going to pass the Web3 handler function an account as props to this navigation component. And if the account is loaded, we're going to display the account's address. And if not, we're going to display a connect wallet button that, when clicked, will trigger the Web3 handler function. Now let's go back to our app and import the navigation component like so. Then we're going to put the navigation component where the previous navbar used to be, passing in the Web3 handler function and the account as props to it. Next, let's go ahead and set up the different routes for our app inside of this return statement. To do that, we need to import browser router routes route from React Router DOM. First, we need to nest all of this HTML code in the browser router element. Okay. Next, we're going to create a routes element that contains each route below the navigation bar. Next, we're going to create a route element for each of the URL links that we set up in the navbar. Now let's create a new file that will contain the component that will pass into the element attribute for each of these routes inside of this components folder. We're going to create a home component for this path, a create component for this path, a my listed items component for this path, and a my purchases component for this path. Now let's go ahead and import all of these into our app.js file, like so. So one last thing before we start building out the components for each route. To do that, we're going to embed some JavaScript code within this HTML using these red curly braces. Then we're going to check if it's loading, and we use a ternary operator. So if loading is set to true, then we render this, which is a spinner. And if loading is false, then we render the routes. We also need to import spinner from React Bootstrap, like so. All right, now we can start building out the components for the different routes, starting with the home route. So we're going to assign the home component to the element attribute. And for now, we can get rid of these element attributes. We'll fill them in once we get to them. All right, now let's get a quick preview of what our app looks like so far. As you can see, the nav bar is rendering. Let's see if the links in the nav bar work. Create. Sweet. It routes us to the create URL. My listed items works. My purchases work. Awesome. So let's go ahead and start writing the code for this home component inside of this home.js file. Like with the nav bar, I'm going to paste in some boilerplate code to get us started. This home component is going to display all of the listed marketplace items. So we need to fetch the marketplace. So we need to pass in the marketplace contract to fetch all of the listed items, and the NFT contract to fetch the metadata for the associated NFTs. So let's go back to our app and pass in those contracts like so. Moving on, now let's create a function inside the home component that loads marketplace items. We're also going to need to store the items in the application state using the useState hook. inside the load marketplace items function, let's first fetch the item count from the marketplace contract. Then we're going to initialize an empty items array. Next, we're going to create a for loop that will fetch every single item that was created on the marketplace. Then we create an if statement that checks if the item is unsold. Then we get the URL from the NFT contract for the unsold item by calling the token URI function on the NFT contract, asking the token ID. Then with that URI, use it to fetch the NFT metadata stored on IPFS. We do that using JavaScript's fetch API, passing in the URI. Then we get a response, and on that response, we call the JSON method, and then that returns the metadata. Then we get the total price of the item by calling the getTotalPrice function on the marketplace. And lastly, we add the item to the items array that we declared up here, calling the push method on it. And we pass in an object with the following properties: the total price, the item ID, the seller, and for the name, we get that from the metadata, the description for the metadata, and the image from the metadata as well. All right, and once we've fetched all the unsold items, then we add them to the state like this. We also want to keep track of when we are loading marketplace items. So we could do that using the useState hook. And then we'll set the loading to false at the end of this load marketplace items function. Next, we're going to create a buy market item function that allows users to buy market items. We'll pass in an item as input. And first, we're going to call the purchase item function on the marketplace, passing in the item ID from the item argument. And for the ether sent with the function call, we'll pass in the item's total price. And that's going to return a transaction response. And we're going to call the .wait method on that transaction response. And what that's going to do is it's going to wait for the transaction to be confirmed. And once that happens, we're going to reload the marketplace items, which will remove the recently purchased item from the marketplace, which happens each time the URL path changes from one of these back to home, or when the user presses the refresh button on the home path. All right, now that we've created the function that loads unsold marketplace items and the function that allows users to buy those items, let's build out the user interface that will display the items inside of this return statement. But first, let's return a loading page if the marketplace items has not finished loading from the blockchain. Moving on, inside of the return statement that will display the items, let's first check if the items array length is greater than 0. And if not, then we're going to display that there are no listed assets. Next, we're going to map each item inside the items array to a card that displays the item's associated NFT image, the name of the NFT, the description, as well as the price of the NFT, and a button that you can press to trigger the buy market item function for that particular item. So that's going to look like this. We will display the item's image at the top, followed by the name, description. Then at the footer portion of the card, we will place a button that when clicked triggers the by market item function, passing in the item. And we're also going to display the total price of the item in ETH. So to do that, we need to convert the item.totalPrice from Way to Ether using the ethers.utils format ether method. Alrighty, and that completes all of the home component. Now let's check out what the app looks like now. So here it is. Let's go ahead and connect our wallet for the first time. Awesome, and it works. So right now it's displaying no listed assets because we haven't called the make item function on the marketplace yet. And really quickly, let's go ahead and center this no listed assets to where it's located right here. We can do that quite easily by returning back to the app.js component, going to this div, and then setting the class name to app. Okay, let's see if that fixed it. It did. Awesome. All right, now let's finish building out the create, my listed items, and my purchases components. All right, now let's start building out the create. All right, now let's start building out the create component. So go ahead and, all right, now let's start building out the create component. So go ahead and open up create.js file. And we're going to paste in some boilerplate code. This time we're going to import the IPFS HTTP client. This will allow us to upload the metadata about the newly created NFT to IPFS. Let's set up the state of the create component. So we're going to need to keep track of the NFT image, its price, the name of the NFT, and its description. The name, description, and image will represent the NFT's metadata, and the price we will store on the blockchain. Now we're going to create an upload to IPFS function that will get triggered each time there's a change to the file input field on the create form. This is the field that users will use to upload the NFT image. So inside of here, we're first going to prevent the default event trigger from happening. And then we're going to fetch the file from the event and then the first element of the files array inside the target. Next, we're going to create an if statement that actually checks that a legitimate file was inputted by checking the type of the file and ensuring that it's not equal to undefined. Then we're going to create a try catch block to potentially catch any errors in the process of uploading the image file to IPFS. And if there is an error, we're going to log that to the console. So to upload the image to IPFS, we simply call the add method on the IPFS client, passing in the file. Then we await for it to return a result. We're going to console.log that. And then we're going to set the image to the link where you can find the image file on IPFS. Next, we're going to write the create NFT function, which will get triggered when the user clicks submit on the create form. This function will first upload all of the NFT metadata to IPFS, which will include the link to where you can find the image on IPFS, the name, and description. And after it's done interacting with IPFS, this function will interact with the blockchain to mint and then list the NFT for sale on the marketplace. First, we're going to check that the image, price, name, and description fields on the create form were all filled out. And if any one of them aren't, then we're going to return. Next, we're going to add a try catch block, just like we did for the upload to IPFS function. So we're going to add the metadata to IPFS in JSON object format by passing an object with the image, name, and description of the NFT to the stringify method. Then we're going to pass all of that to the add method on the IPFS client. We'll wait for the result, and then we're going to pass the result to a function that mints then lists the NFT. Let's declare that function down here like so. We're going to pass the result to the mint then list function. We're first going to set up the URI URL that points to where the metadata for the NFT is located on IPFS. Then we're going to mint the NFT, passing in that URI data to the mint function. But first, we need to convert the user inputted price in ETH to Wei using the parse ether method, and then setting that to listing price variable. Then we're going to call the make item function on the marketplace, passing the NFT address, NFT's token ID, and the listing price. Alrighty, now we have all the functions we need to create and then list NFTs on the marketplace. Now let's start building out the form that will trigger these functions. The form's going to look like this. So at the top, we're going to have an input field of type file. And this is going to be the field where users will upload their NFT image. And whenever there's a change to this field, we're going to trigger the upload to IPFS function. Then below that, we have the field for the name of the NFT. And when there's a change to it, we're going to trigger the set name function, passing in the name on the input form. We're going to do the same thing for the description, except the input field is going to be of type text area instead of text. And we're going to do something similar for the price field. And the input field is going to be of type number instead of text. Lastly, at the bottom of the form, we're going to have a button that, when clicked, triggers the create NFT function. Awesome. And that completes the create component. Now, let's do one last thing before we check out what our app looks like. Let's go back to the app.js component. We need to pass the create component to the second route for the create path, just like we did for the home component. So we'll do that like this. Now let's take a look at our app. Okay, create. Sweet. Now let's go ahead and test it out. See if we can create and list an NFT that will be displayed on a home component. So let's click choose file. And I'm going to choose Gov. We'll say Gov Majestic and blue for the description. And we'll set it to the price of 3 ETH. Now let's click create and list NFT. Hopefully everything works. Okay. We have the first MetaMask prompt. This is to confirm the transaction to mint the NFT. Okay. The next is to approve the marketplace to spend the NFT. And the last will list the NFT on the marketplace. Hope it works. Okay, let's check the home component. Awesome, woohoo. Here it is. Here's the image of the NFT, description, name, description, and a buy button. Buy for 3.03 ETH. We're displaying the total price of the NFT, so the price set by the seller plus the market fees, just so that users aren't confused when they click the button and they see, wait, I thought the price was set to 3 ETH. Why is it charging me 3.03 ETH? All right, all we have left to do to complete the app is finish building out the MyListed components and the MyPurchases component. Both of these components will only read data from the blockchain, not write any data. So building these out will be easier compared to the home and create components. So let's go ahead and open up the MyListed items file and paste in some boilerplate code. For the MyListed items component, we're going to pass in the contracts as well as the account that's connected to the app. We need this account in order to filter out the marketplace items that the user has listed. For the state of this component, we're going to track when it's loading the user's listed items, and of those listed items, which of them have been sold. Next, we're going to define a function that loads all of the user's listed items, and we're going to use the useEffect hook to call this function each time the MyListedItems component is mounted. Inside this function, we're first going to get the item count from the marketplace, then declare an empty listed items array and an empty sold items array. Then we will create a for loop that will return every item created in the marketplace. Then we're going to create an if statement that checks if the seller of that item is equal to the account that we passed in. And then we're going to get the URL from the NFT contract and fetch the metadata in the same way we did for the home component. And then we're going to get the total price of the item from the marketplace. Then we're going to define a listed item object, passing in the total price as a property, the price, the item ID, the name, metadata name, description, metadata description, image, metadata image, like we did for the home component. And then we're going to push that item to the listed items array. And if the item has been sold, then we're going to push it to the sold items array. And once we have fetched all the listed items and sold items, then we're going to set loading to false, set listed items, passing in the listed items array that we filled. And for the set sold items, pass in the sold items array that we filled as well. All right, and that's all the data we need to load for this component. So now let's start building out the UI. Like with the home component, we're going to display a loading page if the data is still loading. And once the data is finished loading, we're going to return the listed items right here. But first, we need to check if the listed items array length is greater than 0. And if it isn't, then we're going to return a no listed assets header. When we do have at least one listed item, we're going to display a header at the top center portion of the page that says listed. Then we're going to map through the listed items array. And we're going to, for each item, we're going to display a card similar to how we displayed each item in the home component, except we're just going to display the image of the item as well as the total price in ETH of the item in the card footer. And below the user's listed items, we're also going to render their sold items if they have any sold items by calling this render sold items function. Let's go ahead and define this render sold items function at the top of the file above the MyListedItems component right here. We're going to pass the array of sold items to it, render a sold header, and then map through the sold items array, displaying a card for each sold item, like we did for the listed item. But for the footer, in addition to displaying the total price of the item, we're also going to display the price that the seller set the item at. So the price that the user set the item at. And then we're going to say that's the received ETH. Alrighty, and that completes the MyListedItems component. Now let's go back to the app.js component and add the MyListed component to its corresponding route, like so. Now let's check out how our app looks like. Okay, let's hit the MyListedItems. Sweet, awesome. So that NFT we created earlier, we see that it's displayed here as one of our listed items on the market for a price of 3.03 ETH. All right, now let's try to buy back our NFT to see if the MyListedItems component will show it as a sold item. So go ahead and do that. Buy for 3.03 ETH. This will also test to see if we configured the home component correctly. Let's go ahead and buy it. Confirm. Awesome. So it's been removed from the home page as we expected. Let's see if it's on the MyListedItems as a sold item. Sweet. Awesome. So it was sold for 3.03 ETH and we received 3.0 ETH. Nice. Okay, let's finish up this tutorial by building out the last component, My Purchases. So go ahead and open up the My Purchases file. I'm going to paste in some boilerplate code. And like with the MyListedItems component, we're going to pass in the contracts and the account connected to the app. We're also going to keep track of the purchases. So these are the items that the user has purchased. And we're going to load them from this function. And we're going to call this function each time the component mounts using the useEffect hook. Next, we're going to fetch purchase items from the marketplace by querying events with the buyer set as a user. So the way we do that is we call the query filter method on the marketplace contract. And then we have to pass in a filter. And this filter defines the specific events we're looking for. And we can create one by calling the filters method on the marketplace contract. And then on the filters, we specify the name of the event we're filtering for, so bot. And then for each of the bot fields, we input the value that we're filtering. If we're not going to filter for a specific field, we set it to null. So we're going to do that for all the fields except the last one, which is the buyer field, we'll set to account. Next, we're going to map through the results array in order to fetch the metadata and total price for each of the purchased items, and then assign the returned array to this purchases variable. Because this results.map method has to potentially perform multiple asynchronous operations, we have to cast it inside the promise.all method in order for us to assign the returned mapped array to this purchases variable. Moving on, inside the asynchronous callback for the map, we get the arguments from each result, and then we get the metadata from IPFS and the total price. Then we define the listed item object, which essentially combines the metadata and blockchain data about the item into a single object. Then we return it. All right, and once we've loaded all of the user's purchased items, we update the state to reflect that. Sweet, now that we've configured this component to load purchased items, let's go ahead and build out the user interface for it. So first we check that the purchases array length is greater than 0, and if not, we display no purchases. If the purchases.length is greater than 0, we map through the purchases array, displaying a card for each purchased item. The card will contain an image of the NFT at the top, and for the footer, the price that the user purchased the NFT for. Okay, and that's it. We have coded out all of the different components that make up our application. So the last thing we need to do, go to this our app.js file, and then add the my purchases component to the final route right here, like so. Okay, save it. Now let's check out the completed app. Hopefully everything works as expected. Refresh the page, connect it, home page, no listed asset, create, my listed items, okay. My purchases, awesome, awesome. So the NFT that we created and then purchased back for ourselves is listed in the purchases page, and it's also listed in the my listed page because we were the ones who listed it, and technically it was sold, but we were the buyers. So yeah, it looks like everything is working as it should, and of course there's no more available assets on the marketplace to buy. So yeah, that's to be expected. All right, there we have it. That's the completed project. You have successfully created Dapp NFT Marketplace, where you can create NFTs to be listed on the marketplace, buy them, and view the NFTs you've listed, the ones that have sold, and the NFTs you've purchased. You should give yourself a huge pat on your back. You have come a very long way since the beginning of this tutorial. You learned about blockchain, smart contracts, how to build an NFT contract, a marketplace contract, how to write tests against them to ensure that they are working as you expect them to, and how to build a client-side application in React.js that connects to the blockchain. There are a few ways you can improve upon this project. For instance, you could make it support multiple different NFT collections. You could also make it such that each NFT listed for sale, the price is not fixed. It counts down, sort of like in a Dutch auction type style. If you're trying to become a professional blockchain developer, you can add one of the features I just mentioned to this project, then showcase it on your portfolio. So if you want to check out this project's entire source code, the link to it is in the description down below. And if you really enjoyed this tutorial and want to take the next step to mastering blockchain, head on over to dappuniversity.com/bootcamp. Inside of there, we teach you how to build a full-fledged decentralized exchange with limit orders. It's a very complex Dapp that you can use to build your portfolio. And make sure to leave a like, subscribe. It really helps to promote these videos to more people who are interested in learning about blockchain. All right, until next time, bye.